Anagalactic, bringing you another presentation, our first in the year 2024. Currently, we're offline here, so this is being recorded for a future date, but today is January 3rd, and I'm happy to say that we're beginning a new series in hyperspheric geometry, the result of 2 years of work and 2 years, very nearly, of uploads to YouTube on the channel ÆIOU. The AE is a ligature, so-called from Latin. Technically, that would make it only 4 letters. AE is 1, then IOU. It stands for Anagalactic and Extragalactic Interactive Online University. Unfortunately, the second clause, if I could put it that way, has never come true. It's never become interactive. However, to a certain extent it is. One can always leave comments. I welcome any comments. And I am totally open to answering your questions, or indeed engaging in further communication, perhaps by email, should that become suitable to you. There's not much I can do to reach out to you, except the way that I'm doing. But today we begin an outline, and I'd like to show you what we're going to be covering in this rather simple outline. This basically summarizes the work that I've done over the past 2 years. You can see that there is a wide range of topics, but they're all in the category of cosmic science. So let me just read through this in order to show you where I'm at. I'll be highlighting this. Let me make sure that that looks... I call these discoveries because I can't find anyone else who talks about these things. And I have made a couple of discoveries that I am attempting to publish in Archive with a LaTeX document that's due out in spring. So you're really getting something up front here. But these are the topics that I've arranged. You can see that there are 7 topics, but really all of this fits together. So let me read through this. Mathematic and geometric topics are the main topic, are those 2 very closely related topics of mathematics and geometry. In geometry, I've been concentrating on the sphere, which falls under the category of curvature. The relationship of the sphere to the linear system that we use for our number system is interesting, and I cover that in great depth. In the third category, you'll see quantum physics, or quantum physics. It's usually with an S at the end. The physics of the quantum. Because I concentrate on geometry, I tend to show sides of popular and extant topics, contemporaneous topics, that are not commonly seen from the angle of geometry. It's rather important to have a geometric basis for physics, but that has been neglected, and I like to think, I certainly hope, that I'm filling in a gap that has long needed to be filled in, the geometric side of physics. In the next, what's labeled 4 there in Roman capital numerals, cosmologic, this is how I began. I am essentially an astronomer, a deep space astronomer, who became extraordinarily fascinated with galaxies, and it spread out from there. No more on that. The next 3, 5, 6, and 7 are familiar to most everybody these days in science: the proton, the electron, and the photon. It's really the photon that I personally am most interested in. However, in order to get at the geometry of what I call the flight of the photon, it is necessary to understand the topics which are coming up. So in the second column over here, you'll see that I have this expanded a bit. This would be the mathematic and geometric topics that I intend to cover more fully. What you see highlighted in red is the spheric system, which I claim to have discovered, it's always hazardous to say that you've discovered something until you get consensual feedback, or some kind of feedback, giving either a thumbs up, a thumbs down, or nobody's sure, but I haven't gotten any of that yet. And of course, the next step is to produce that LaTeX document for publication in Archive. Now here we have the geometric side, but you'll see that I cover topics that are not ordinarily covered in geometry. First of all, infinity. Infinity is a major problem. I think it's safe to say that infinity is a problem. And I have a geometric aspect on that I think you will find most extraordinary at the very least, if not helpful. I trust that it will be helpful. Sphericity, this is the main topic that I cover because I claim, and I've done enough research now that I think that I am substantially correct, that there is no geometry of sphericity. There never has been. However, that could be argued because spherical space has been approached through linear geometry. That is, the only system that science has ever used has been the linear system for fairly obvious reasons, 1D, 2D, and 3D, and of course space-time is 4D, and D means linear dimension. Hypersphericity is the latest of my discoveries. It is an extension of hyperspace, which is again linear. And if you look up hypersphere on the internet, particularly you could start, if you like, as I do, with Wikipedia, you'll find out that there is no such thing known to science as hypersphericity. It's known of, but nobody knows what to do with it, and therefore nobody has ever done anything with it. You will find exceptions to that because scientists are extraordinarily curious. However, what you'll find, although it may be interesting, will not explain the hypersphere whatsoever, but I will. In the third category over here, we have the quantum. The quantum, of course, is at the top of the list, along with, it's a very short list of cutting-edge topics. But the quantum, we're talking about quantum mechanics, of course, and a lot of spooky things and a lot of controversial things that have been so for over a century. Over a century. I claim to have some major insights into quantum mechanics, which I trust you'll enjoy. At the very least, you will enjoy it. We need to get the definition of the quantum. That's extraordinarily important. It's very rarely stated. For a fairly good reason, it's a paradox. And a paradox has a direct effect on the ability to define what it is you're even talking about. The visualization of the quantum, that will be due to Ruger Josip Bošković's insights, and you'll see I have him down here under articles. The Bošković force curve system gives a visualization of the quantum for the first time in history. And that is saying a lot. I hope you can trust that at least long enough to hear it. And the implications of quantum mechanics, that's mostly scientific, sociological, and scientific philosophical, but it has brought up some amazingly fascinating topics, which I consider to be, although they're, it's grandstanding, there's a lot going on that has to do with getting viewers, for instance on YouTube, and getting attention. So a lot of it is hype, but the implications of quantum mechanics cannot be denied abstractly. It's just the way it is. Now on the cosmological side, our last major category here, you'll see that I talk about SMBH morphology, and you may never have heard that word morphology, and you also may have never heard anybody pronounce such a suffix with a hard G. Don't worry about that. I'll be covering that and explaining a lot about why I even say the things that I do say, such as morphology. In the next one down, we have the quasar. The only other luminous object in the universe besides the star is the quasar, and of course the galaxy, which for me is coming full circle. Now, under articles, we need to speak about space-time, of course. We're going to be covering space-time in extraordinary detail in a way that I am quite certain you've never heard. And I think you're going to find it quite enlightening. I trust so. I certainly have. And then the Boschkovich force curve system I've already mentioned. Now I would just like to interject here why I have this outline. Why am I showing this to you? What does it signify? It's to give you an idea of what's ahead, but also these topics that you see listed here I'm projecting, but it is my intent to produce very short lectures on each one of these so that they fit together. And when I say short, I mean about 10 to 15 minutes each. I don't believe, although this is quite going out on a limb, I haven't done a poll and I don't have too much data, but I believe that the audience that goes out to the internet, for instance to YouTube, to get scientific information is statistically constrained in the amount of time that people perceive that they have for this kind of thing. You would have to be extraordinarily attracted, probably over a period of time. A form of trust, a bonding is formed between you and some presenter or some channel, perhaps some topic in particular that would lead you to spend any more time than is absolutely minimum. People are always in a hurry, particularly Americans. But it's true of everyone. We're looking for succinctness. We don't want things to be stretched out because it's perceived as a waste of time. Even if you're interested, if it's tedious or takes too long. So I'm attempting to make 10-minute lectures. At first, I've produced over 400 videos so far. And when I started out, they were about an hour each. I cut it down to 40 minutes each, and then to 30 minutes each over the past few months. And over the past few months, that is, in the fall and winter of 2023, I did produce over 100 more lectures. So this has been quite continuous, basically for a year and a half. I started this channel in June of 2022 for the purpose of documenting a discovery sequence that I thought had come my way. That has been amply justified, but also so I could listen to these. So this is for myself as well as for you. The next topic down, again, for perhaps a 10-minute lecture. All of these fit together, though. The SMBH, of course, is the supermassive black hole. I call the center of it the anti-singularity. That's in direct defiance of modern cutting-edge physics, which I am absolutely certain is completely wrong about the black hole. The quasar, as I mentioned earlier, it's up here under cosmologic topics, but the quasar is very closely related to the supermassive black hole, and I'll be covering that so that you have at least a second theory, I'll call it that, a second theory of what actually is a supermassive black hole. Of course, that's another topic that's been at the top of the list in deep space astronomy for decades. I believe there is virtually no understanding of that object, and it's critical to have that understanding if you want to understand the universe, which indeed is the entire purpose of this channel, is to help you and me understand the universe. Calculus. I have an extraordinary insight into calculus. That's all I'll say for now because we're running out of time. Complexity and imaginarity. These two terms are related. Complexity is a very unfortunate term, but we're stuck with it now because complex sounds like, well, my goodness, why would I want complexity? Actually, it's simpler than that. However, there is some justification for saying it's complex because it's a second form of algebra. Imaginarity was forced because of the real number system, the number system called the real number system, one of the most unfortunately named mathematicians are extraordinarily well known for very, very stupid names. So the real numbers forced out imaginary numbers because complex numbers are two-component numbers. We'll cover that. The antipodal theorem is something I claim to have discovered. I don't find anything in the literature or online to deny that I discovered this. It basically proves that linear space is embedded in spherical space mathematically and geometrically. In other words, they're related so that one can be converted to the other. The second theorem, which I discovered very shortly after the antipodal theorem, is the bootstrap theorem, which allows for the construction of space. We already have a construction of space, as you already know, called 3D space. And time-space is an extension of that to 4D space. The D means linear. The dimension, the D stands for dimension, that means a line. 1D means one line. 4D means four lines. And the Einstein field equation, which I didn't really write down here, but under space-time and gravity, of course, is where the Einstein field equation goes. So there will be some very interesting information, I hope you find it so, on how to construct space in a new way that it's not linear, it's actually spheric. Then I definitely want to give you a recount of the history of the quantum from Max Planck all the way to the present day. What is it? I know that you'll find that interesting. It's one of the most recent of my topics. The surreal system, which was discovered by John, I believe it's John Horton Conway. Have I got John? Well, John Conway in any event. He died of the COVID virus about 3 years ago, but he discovered the definition of the linear number. And it's remarkable how little that's published, but I think you'll find that interesting. And then the most recent topic that's come my way is hyperspheric space, the natural extension of the spheric space, which we constructed from these two theorems. We get spheric space. That's a number system. Hyperspheric space is basically analogous to the extension of 3D to 4D. In context of hyperspheric space, we have some new insights into the definition of time. What is it? Its relation to momentum and chirality. I've heard that pronounced chirality sometimes. That might be European, but I believe Americans say chirality. That's how I say it. Forgive me if that sounds strange. Gravity and light speed. Now, we've already mentioned gravity up here with space-time, but this is to relate gravity and light speed very closely together. They have symbols. G is an international unit, and C, of course, is a two-dimensional international unit. I believe gravity is a three-dimensional. This is a slightly different use of the word dimension. It means the number of units in the unit, because there are base units and then there are compositional units. Both gravity and light speed are compositional units. Light speed, of course, is composed of the two base units, the one for distance, which is for space, and that is the meter, and the base unit for time is the second. Gravity, we'll cover that as well. And then the Dirac equation, on which I've given my most popular lecture. It has over 300 views. Not much by YouTube standards, but very much by my standards. I only have a handful of videos that have been watched over 100 times, so 300 is pretty good. I think it's one of my better early lectures. So I hope that that's given you a good introduction to what's ahead in 2024. Again, this is early January, January 3rd in Chico, California. This is Anagalactic bringing you the secrets of the universe. I do have over 400 lectures published. Currently, I only have about 300 of them public. I've taken some of them offline just because they got no views. When you only get 3 to 4 views, and you see that, it's kind of depressing, so you make it private, and it doesn't show up. That might change. I might become famous someday. I'm not too concerned about that. My main purpose in giving these lectures is to instruct myself to keep going on this amazing discovery vector, which has done wonders for me. But in science, we share. It's communicative. Private science is not science, only if it's shared. The way we know what to share is by proof. If you have proofs that can be consensually accepted, that can be unfair. A lot of people who have made discoveries have even died without their discoveries being recognized. Again, I am not greatly concerned about that, except on behalf of science. On behalf of myself, I have no concerns whatsoever. I'm not after money or fame. I'm trying to achieve my own personal goals, and this has been the ride of my life. I'm very close to 70 years old now, and I can tell you that this has been very worthwhile for me. I hope it is for you as well. I hope you have a very good time. Stay tuned to Anagalactic for some of the most amazing stuff you're ever going to hear in science. I've been practicing for 2 years to give these lectures, so I've become better, much better than I was even a year ago, even 3 months ago. All right. Thank you very much for tuning in, and we'll see you next time. Don't forget to keep looking up. That's where you're going to get the real insights, by looking into the night sky.